topic by topic. Today we're going to have a look at sequences, arithmetic, geometric. We're going to have a look at some of those and see what we can do. You've met these sort of sequences in GCSE, and what we're going to do is take them a little bit further and have a look and see what we can do with them. So let's start with a very basic sequence and see what we can do with this. So let's take a nice sequence which we might have met at GCSE, which would be something like 3n plus 5. So what I'm going to do is I'm going to say, basically, I'm going to change that just a little bit, and I'm going to say my next term here is going to be that, un. So let's see if we can try some things out. If I set n to be equal to 1, then 3 ones are 3, plus 5 is going to give me 8. If I've got n is equal to 2, then it's going to be 2 times 3 is 6, and 6 and 5 make 11. So we can go through all of these numbers one by one, working out what our sequence is. Maybe we're asked to work out perhaps the first 5 numbers of a sequence, and we can rapidly work out that if we're doing this with an arithmetic sequence here, the difference here is going to be working out here, it's going to be a difference of 3 between each of these, with a starting number there basically set to 5, because that's when n is 0. 0 times 3 is 0 plus 5. So that would be our initial value. And so we can just go on adding here in 3s, working out what we want. Maybe we're asked to find out when u is, any number, 50. So we can do that in exactly the same way of multiplying 3 50s, 150, plus 5, 155. Now, these are relatively easy things to do. Sometimes you might get this problem given to you perhaps another way. Let's suppose we've got a sequence which goes something like this. un, the nth value of our term, is going to be a times n plus b, and we're told that when we've got the 5th term we get 18, and 3rd term we have 18, and the 8th term will have 38. And we're asked to try and work out what we've got. Well, we've got an easy way of trying to do this, because we know it's the 3rd term, so our answer 18 equals, here we know n's going to be 3, so it's going to be 3a plus b, and we know that 38 is going to be 8a plus b. And we have here a simple simultaneous equation which we can solve, and we can do this, and it's probably easier to take away this. So I've got minus 18 plus 38 is going to give me 20. We're going to get here 5a, and the b is going to cancel, so a is going to equal 4. And we can then put this in and say that I've got 3 4s are 12, plus b equals 18, so therefore b is going to equal 6. And as we do so, we can say therefore our answer is going to be u to the n is going to be 4a plus 6. So we can do it one way, we can try it another way, we can do this differently. Let's just divide that one up and say we could do, we've got a sequence, I know, let's go for 6, 20, 34, 48, 62, and we've got to try and find the nth term, and to do this it's not going to be that difficult again, because we've got un equals an plus b. We look at these terms and we look at what we've got. So we've got 14 here, and if I want to try and put this in, then we've got to try and work out what we've got a difference. I've got to work out my first number here, and that's going to be 14 minus, so if we just put this in to work it out, I've got 14n, so when n is 1, so we've got 14n, that gives me that. 14, to get back to 6, we'll need to minus 8, and that gives us our nth term. So not really that bad trying to work out some of these. They get a little bit more difficult when you try to get a few negatives in there, but basically they're relatively easy. Now what we can do is we can get here an idea of a formula for this, and that's going to say that the nth number here is going to be a plus my number minus 1 times the difference, the common difference. Now where we start getting more fun at A level is, let's see if we can actually work out the summations of these. I'm always upset by the fact that when I started sort of doing maths, I started solving these when I was reasonably young, but the first person that I know that did this was a young gentleman called Gauss, and he was given some of these little problems to sum up, and he actually worked out what the formula was to do it, and he did that when he was much younger than when I started. So if I want to work out the sum of all these terms, it's going to be the number of terms divided by 2 times 2a plus our n minus 1 times our difference. So a here equals the first term. We've got d here, the common difference. You can also write this a different way if you know the last term. And that's again going to be a plus l, and l here equals the last term. So we might get a sequence that we can try to sort of work out. So let's suppose we want to work out some terms, I suppose. Let's have a look at. So we might want to work out perhaps the first 50 terms of some sort of arithmetic sequence, and we're going to start with a number. So let's do this. So let's choose a sequence, and let's go on and do something easy. Let's have 4 plus 9 plus 14 plus 19. Yeah, nearly could see that. So there is our sequence of numbers, and we might want to try and find perhaps something fairly easy. We might want to choose the first 50 terms. So if I want to try and find the first 50 terms of this, so that everything got caught up, where do we start? Well, let's work out what A is, let's work out what D is, and now we can work out the sum of the first 50 terms is going to be my number 50 divided by 2, and then we've got here 2 times the A, so A is in this case 4. Then we have plus n minus 1, so that's going to give us here 49 times our difference, which is 5. And at this point we're going to use the calculator to try and help us do this work. So I've got 25 times 8 plus, and I'm not so good on my 49 times 5. Yes, I can cheat and do that, but we've got the calculator, and so we can work out that's 245.
I don't know that one.
I'm very pleased to see that I can beat the Alexa device, and now we can add on our 8, and what we can do is we can multiply 253 by 25, giving me the answer of 6325. So we can solve these things relatively easily just by putting in these sort of numbers. We could have the same sort of sequence. Let's just take that same sequence. So I've got 4 plus 9 plus 14 plus 19, and we might be given the problem to say, right, what's the minimum number of terms which is going to just be less than, I don't know, 1,000. Okay, so we're going to have this sequence where we're just going to have this one where we're just going to be the number where it's just going to be, we're going to find out where it's just going to succeed, the least number, if you like, where it's going to exceed 1,000. So we've got our formula. Let's remind ourselves, Sn equals n over 2 times 2a plus n minus 1 times d. Okay, so we'll put in our total here. It's going to be 1,000 equals, we don't know what n is because that's what we're trying to find in this case, and this is going to be 2 times 4 plus, I don't know what n is, n minus 1 times here the common difference. Let's try and work out what we've got. So I could multiply that by the 2, so we can say that 2,000 here is going to equal n times 2 4s are 8, and we've got 8 plus 5n minus 5. Let's now just sort that out because it's going to be easier to sort out. So we've got 8 minus 5 is 3, so I've got 5n plus 3 equals 2,000, and if we set this up, I've got 5n squared plus 3n, and if I bring over the 2,000, we've got simply a quadratic to solve. And we don't have to worry about this one too much because all we've got to do is go to our calculator, and since we're allowed our calculator, we can go in and we can choose to solve here a polynomial to square, and we've got 5n squared plus 3n minus 2,000. And I come up with my answers: 19.70 and minus 20.30. So it's unlikely that I'm going to get this negative number. So we've got here 19.7 terms, which is going to mean that I'm going to get 19 terms to try and work out my answer. So we reject that one, we accept this one, and therefore it's going to be less than that one, so it's going to be 19 terms. So a way of trying to do this, to try and work out what we're going on and doing. And arithmetic sequences then really are just when someone's going to give you some sort of awkward type of equation to try and work out, and then all you've got to do is try to sort of work out what is n, what is a, what is d, and fairly easy to try and solve some of those. Okay, let's have a look then at another type of sequence which works in a similar way, but this is a geometric sequence. Now, a geometric sequence is basically where we're going to have a different system. So let's take some numbers: 2, 4, 8, 16. Here, each one we can see is multiplying by 2. And the formula for the nth term for this is going to be a r to the n minus 1, where a here equals the first term and r equals the common ratio. At GCSE, these always seemed very much harder because normally you weren't given this formula to try and work things out. And once you've been given this formula, then things are so much easier. So let's have this sequence and see if we can work out what is perhaps the 10th term. So to work out the 10th term, I need to know our first term, which is going to be here 2. We want to know our common ratio, and our common ratio here is going to be 2. And our 10th term minus 1, so it's going to be 10 minus 1 is going to give me 2 to the 9. So all I need to do is work out 2 to the 9 times 2, which is in fact very easy because that's going to give me 2 to the 10 by pure luck here, and I can simply pop over to the calculator and put in 2 to the power of 10, and that equals the wrong menu. 2 to the power of 10, there we are. And I worked it out. I could have told you what that was anyway, but we might as well just try and do it simply. Let's have a look at a different sequence, one that's a little bit nastier. Let's suppose we've got a sequence that goes 40 minus 20 plus 10 minus 5, and so on. Okay, so let's look at what we've got. Well, our A for this is going to equal 40. My common ratio is basically going to be minus 20 over 40, which is going to give me minus a half. You can always check that by trying another one if you want to. Minus 20, and that's going to be 10 over minus 20 again will give us minus a half. So we can work out our common ratio quite easily. And let's suppose we're asked to find the 10th term again. So u to the 10 is going to be a, which in this case is going to be 40, times a half to the power of 10 minus 1, which is going to give me 9. And this is a minus a half. So now I've got to work out what a half to the 9 is. That's going to be 1 over 512. Times 40. And so that's going to give me 40 over 512. And for ease, I'm going to work that out. 40 over 512. And I reckon that gives me, yes, 5 over 64. And that would be minus, so will this be. So there. This has to be a minus because it's a 9, and therefore we've got that one, we can work it out. If you're asked to work out what is maybe the nth term of this, it's not really quite as nice. So let's see if we can work out what the nth term of this is going to be. The nth term will be 40 here. This is going to be times minus a half to the power of n minus 1. And can we do anything with that one? Let's try. 40 is going to be 5/8 now times minus a half n minus 1. I'm thinking here that that's going to give me 2 to the 3. And the other one's going to give me 5 times that, which is going to be 5 over 2 to the n minus 1. I'm thinking here I've got that, and I can divide by that one. So a bit horrible. I've got, take out the minus, so I'm going to have minus 1 of n to the minus 1 times 5 to the over the 2 to the n minus 4. I'm not actually certain I made that simpler. Just thinking through the way I did that. It probably is. So we've got some of those. Right. Where do you get some problems with some of these? Well, let's suppose we look at this one a different way, and we're starting to have to sort of delve in and try and work out what A and R are from our sequences. So let's have simply here, we're going to say that the nth term here is going to be our AR to the n minus 1. Okay, and let's say that our second term is going to equal 4, and let's say our fourth term here is going to equal 8. Now let's see if we can work out something, and we might have to work out perhaps the 10th term again. So what have we got? Well, let's see what we know. We know that A times R is going to equal 4, and I know that AR cubed is going to equal 8. To work out our common ratio, it's going to be 8 divided by 4. Now that's going to be AR3 over AR, which means that this is going to be R squared equals 2, so that R is going to be the square root of 2. There we are, not too bad. So I've now got this. I've got to try and work out what A is. So A now is going to equal AR is going to equal 4. So we can say that r is the square root of 2, a root 2 equals 4. So we can work out simply that a is going to be 4 over root 2. So a is going to equal 2 root 2. If I'm trying to work out the 11th term, 10th term, 9th term, 8th term, don't matter what it's going to be, I suggested 10th term. Okay, so let's work out the 10th term. So we know our nth term here is going to equal ar to the n minus 1. I'm going to work out my 10th term. So we've got 2 root 2 times root 2 to the 9. Now for that I'm going to cheat, and I can use the calculator if I want to try and do that. Surprisingly, the calculator usually copes quite well with many of these things. So let's just try 2 root 2, and then I'm going to multiply that by root 2 didn't like that one, did it? Root 2 to the power of 9. And it gives me 64. So, worked out quite nicely, that one. Now, what else could we do with geometric sequences? Well, we summed arithmetic sequences up, so it makes sense that we can do that with geometric sequences. So here, the sum here is going to equal a 1 minus r to the n over 1 minus r. And we do that when we've got this done round a particular way, because basically we've got two choices. So if r is less than 1, we use this form, and if r is going to be greater than 1, then I can use this form. And it just makes life a little bit easier when you're trying to work out what you're actually doing. So let's try summing up a geometric sequence. Let's have a think. Right, we've got something like 2, 6, 18, 54. Okay, so let's have a look and see what we've got. Well, a is going to equal 2 here, and r is going to be simply 6 over 2, which gives me 3. I can try all the others, but they would work the same. And let's see if we can work it out for the 10th term. So we're going to try and work out the sum up to the 10th term. Let's choose one of these formula. That one's going to be the easiest one to choose in this case because r is greater than 1. So let's put into this formula for my 10th term. We've got 2 times r, which is going to be 3 to the n minus 1, and for the 10th term then n is 10, so that's going to give me I've written that wrong. That's where I wanted to write it, so that's going to be 3 here to the 10 minus 1. I just wrote it in the wrong format there, really confused myself there, and that's going to be 3 minus 1. So off we go to the calculator to work this one out, and we've got here, let's just do it an easier way, which is going to give me 3 to the power of 10, which is going to give me that, right, so it's going to be that minus 1 and it's going to be that times simply 2. So I've got that number divided by 2. And done that, and it comes out with 59048. And there's the sum of my geometric sequence. Geometric sequences tend to have very large numbers here if you're not careful. Sometimes we can make this a little bit more difficult for ourselves, and we might want to sum to infinity, and typically when you're going to do that you want a convergent geometric sequence, and if we've got one of those, then let's see if we can work out how to do that. Summing to infinity for a geometric sequence, so summing to infinity is going to be much simpler. It's going to be a over 1 minus r. So we can try the sum to infinity of a sequence here. So let's suppose we've got some sort of sequence, and we just literally just throw those numbers in there so that we can work out what the answer is. I'm just trying to think of a nice sort of convergent sequence. So if we want to, we could do, I know, 10 minus 5 plus 2.5 minus 1.25. There I've got, I hope, a convergent sequence, and A is going to be set here to 10. Now we want to work out what R is, and that's going to be minus 5 over 10, which is going to give me minus a half. So this is going to give me 10 over 1 minus a half, which is going to give me 10 over a half, which is going to give me 20. So summing to infinity is sort of a way of doing this. We can use sigma notation if we want to specify a sum, and this is just where we can use the letter sigma to try and do this, and I might be summing up from numbers from maybe r here equals, I know, 1 to 10, and we'd have that of a particular sequence, and that sequence might be, I don't know, let's make one up, 4r plus 1. So if we're trying to do that, let's see what we know. We know a here is going to equal 5, and then my next number would be 9, my next number would be 13, and so on, and we're going to calculate this up to the 10th term. So I know that a equals 5. My common difference here is going to give me 4, and n here is going to be 10. So now we can shove this in to work out what my sum is. It's going to be n over 2 times 2a plus n minus 1 times d. Let's work out what that's going to be.
Here's your reminder. Take a arithmetic.
Let's try and work this out very quickly then. So that's going to be 10 over 2 times 2 times 5 plus n minus 1 is going to give us 9 times 4, and if we want to work that out, so we've got here 46 times 10 divided by 2, and I need to work out what 5/46s are, because I'm not very good at doing that in my head, and gives me 230. So we've got that working out simply. Sigma notation is just a different way of trying to write some of this, just to keep you happy. So that gives us some of these sort of sequences, and once we've got these sequences we can then start to model them, and we can start to do all sorts of weird and wonderful things, trying to produce all sorts of equations and work out how things work. Probably sort of things that would keep bankers, taxmen happy, some of these nice little sequences. And we'll come back and we'll revisit some of these when we start to have a look at trying to solve problems. But until then, I hope you've enjoyed learning about some arithmetic and geometric sequences. If you found this useful, then please subscribe, and I'll see you again in another lesson when we'll look at some A-level maths topic by topic. Until then, stay safe, take care, bye bye.